Okay, so today for our notes, we're back on page 13 and 14. On 13, you should have had this thing with decimals to fractions, fractions to decimals, this little booklet glued in onto the left. So onto the right today, page 14, we are going to be looking at repeating decimals to fractions. So we can label that. Repeating decimals to fractions. So we looked at this Friday and we looked at it some more today. So now I just want us to write down the steps so we can always go back and reference this. So the first thing we have to do when we set these up is we're going to set x equal to the repeating decimal. As you write these, leave space off to the right to do our example. So kind of separating it into two columns. So set x equal to the repeating decimal. 2, you want to use one of those equations that we looked at today. So usually it's either 10 or 100. So we want to multiply both sides by 10 or 100. Our goal, just remember, is to get whatever's repeating, I'm going to call it repeater, to the left of the decimal. So just to kind of remind you some of those equations we looked at today and the day before, we had 10x minus x. You might have to use 100x minus x sometimes, or we even saw 100x minus 10x. I'm going to try to do an example with at least 2 of those just so you can see. And then what you do is set up equation and subtract. So let's take a look at an example. Let's say we want to convert 5 repeating into a decimal, into a fraction. The first thing we want to do, since there's only one number repeating, we would only have to move the decimal once. So after we set x equal to 5 repeating, if you have to write out some 5s just so you can see it a little bit better, that's fine. Or you can just put 5 repeating. Now, since it's only one number over, to get the repeating number to the left of the decimal, we only have to multiply it by 10. So when we do this, when we multiply both sides by 10, 10 times x is 10x, and we multiply this by 10, it comes out to 5.5555 with all the decimals repeating, because we just moved the decimal over once. So now we're going to use one of these equations. This one we can just use 10x minus x. And when we subtract, I want us to always subtract horizontally. That'll help us. So we do 10x minus x. Well, we know 10x equals 5.555 and so on. And we know x equals 0.555 and so on. So when we subtract, we get 9x equals, and then 5 minus 0 is 5. All of these other ones will just cancel. So we're really just left with 5. So once you set up the equation and subtract, the only thing left to do is get x by itself. Or really, we're just solving for x. So now to get x by itself, divide both sides by 9. So now we know x equals 5/9. That's 5 repeating as a decimal. Let's try another example. Say we're looking at 0.24 with the 4 repeating. So again, we want to set x equal to 0.24, and if it helps, write out a couple repeating digits like this. You know it's just going to keep doing that because it's repeating. Then what we're going to do is we are going to have to move this 2 times over. I guess let's change this to 2, 4, sorry. There you go, 2 and the 4 are repeating. So the bar needs to go over both. We're going to have to move this 2 times over. So to do that, we want to multiply by 100. So we'll get 100x equals, move the decimal twice, 24.2424, and so on. So now when we set up our equation, we're going to want to use, this one will be okay, the second one. So 100x minus x, we know 100x equals 24.2424. We know x equals 0.2424, and so on. They both go on forever. Subtract 100x minus x is 99. X, 24 minus 0 is 24, and the rest just all cancel out forever. Solve x, 99, divide, get 99. So we end up with x equals 24 over 99. Now I do want us to try one where we have to use this 100x minus 10x. That equation is useful when we have a problem where only one of the digits repeats, not the other one. So maybe 0.1 and then the 9 repeats, but just the 9. So again, x equals 0.1999, so on. Now again, we have to move this decimal over twice because the 9 repeats. So we have to get that 9 to the left of the decimal. So we're going to do 100x, move it twice, 1, 2, we end up with 19.999, and so on. Now, since we want these, you could do 100x minus x. This one, it would be a little bit easier to do 10x minus 100x, or 100x minus 10x, sorry. So 100x equals this, we know. And if you, again, if you wanted to do just minus x, you'd get the same answer. But if we do minus 10x, well, that means we're just moving this decimal once. So 10x is just 1 point and then all the 9s repeating. So now we subtract. 100 minus 10 is 90. X equals 19 minus 1 is 18. And all of these others 9s just cancel out. Solve. Divide by 90 on both sides. So x equals 18 over 90. We could even simplify this a little bit. Divide by 2 and we get 9/45. And then divide by 9 and we get 1/5.